In this video, you're going to learn about fractions, so it's going to be more of revision of what you learned in primary and junior secondary, and then we're going to focus on basic operations on fractions such as addition, subtraction, multiplication, and division. So let's start with proper fractions. A fraction is a number of the form p over q, where p is the numerator and q is the denominator. This is something you must have come across by now. So that should be an R, that should be an R. A proper fraction is a fraction of the form p over q, where p is less than q. And all that means is that it's a fraction where the numerator has a smaller value than the denominator. For example, a fraction like 1 over 2 is a proper fraction. A fraction like 2 over 3 is a proper fraction. A fraction like 5 over 7 is a proper fraction. The key thing here is that the numerator is less, well, in these cases anyway, the numerators are less than the denominators. So that's a proper fraction. An improper fraction is also of the form p over q, but in this case, p, the numerator, is greater than q, the denominator. You can easily think of examples of improper fractions. I'll give you some. 7 over 6 is an improper fraction. 9 over 8 is an improper fraction. 6 over 5 is an improper fraction. And what you notice is that the numerators in this case are greater than denominators, so these fractions are improper. A mixed fraction is simply a fraction of the form, and I'll use w, p over q, where w is simply a whole number and the p over q is just simply a proper fraction. For example, 1, 2 over 3. So the first operation of fractions we're going to look at is the addition of fractions. Now when you learned this in primary school, you must most likely have used the LCM method. I'm not going to use that per se, so I'll just show you. So if you have two fractions and you're adding them together, so in this case I have a fraction a over b plus c over b. All this means is I have two fractions and they have the same denominator and different numerators. All you have to do is first realize that your answer is going to be a fraction. The denominator of your resulting fraction is going to be the same as the denominator of the fractions that are being added, and the numerator of the resultant fraction is simply obtained by doing the following. So you have a over b plus c over b. You just simply go a plus c, and that's what we get here, and that's your answer. So I'll give you an example. You have something like 6 over 7 plus 2 over 7. We're adding two fractions that have the same denominator of 7. The resulting fraction is such that its denominator is also 7. Its numerator is given by 6 plus 2. 6 plus 2. And that gives 8 over 7. You also need to be able to carry out the addition operation on fractions with different denominators. So here we have a fraction a over b and another fraction c over d. These two fractions have different denominators. In order to add them up, one easy way to do so is to first convert the problem to a case where you're adding fractions that have the same denominator. And one way to do that is simply take the first fraction and multiply through by the denominator of the second fraction. So I'm going to multiply a over b. Well, I'm going to multiply the numerator by d and multiply the denominator by d, or you can think of multiplying the fraction by d over d. That's what I'm referring to when I say multiply through by d. And then you add, because that's the sign we have there. And then you take the second fraction and you multiply it through by the denominator of the first fraction, which is b. So multiply by b over b. And what you get from this is, so you're not supposed to have two equal sign on the same line, but I'm just going to break that rule for the sake of demonstration. So what I'll do is just come here and I'll simplify this first part. I get a times d, which is ad, divided by b times d, which is bd, plus, simplifying this second part, c times b, which is cb, divided by d times b, which is db. So this is what we have, and one thing you need to notice is that db means d times b. So db is d times b, which is the same thing as b times d, which means it's the same thing as bd. So AD over BD plus CB over DB is the same thing as saying plus CB divided by, instead of DB, I can rewrite it as BD. So now it's very obvious that we have two fractions with the same denominator. So the result of this addition is simply a fraction whose denominator is BD and whose numerator is given by AD plus CB. And I'll give you an example. So we have the following fraction, 2 over 3. We're adding it to 5 divided by 2. These are two fractions. They have different denominators. So what I'm going to do first is modify the first fraction by multiplying it through by the denominator of the second one. I'm going to note down the plus sign. Then modify the second fraction by multiplying it through by the denominator of the first fraction, which is 3. And this gives 2 times 2, which is 4, divided by 3 times 2, which is 6, plus 5 times 3, which is 15, divided by 2 times 3, which is 6. So we have two fractions now with the same denominator. So adding them is simply a case of 4 plus 15, which is 19, divided by 6. Another common problem we need to look at is for the case where you're adding two mixed fractions together. And one thing you could do is first convert each of the mixed fractions to improper fractions, which is something you've done in primary school. But another thing you can do is just simply say, well, okay, consider this expression here. A is a whole number part. So this is the first mixed fraction. A is the whole number part and x over y is the proper fraction part. And then the same thing here, b is the whole number part and p over q is the proper fraction. So you have two mixed fractions. Here's the first one, the whole thing here, and this is the second one. So to add them up, all you have to simply do is add the whole number part and then add so you add the whole number part and then you add that result to the sum of the proper fraction parts. And that's what we've done here. So for example, if you have the fraction 2, 1 over 4 plus 3 over 4. First add the whole number part, so it's 2 plus 3, which is 5. And then you add the proper fractions, 1 over 4 plus 3 over 4. So 1 over 4 plus 3 over 4. And that's equal to 5 plus 4 over 4, which is 5 plus 1, which is 6. And for the sake of revision, you know that to convert a mixed fraction to an improper fraction, all you have to do is multiply the denominator by the whole number part and then add the numerator. So it's a y plus x divided by y. So for example, we had the number 2 1/4. We want to convert it to an improper fraction. It's a case of 4 times 2 plus 1 as the numerator. So I'll just do that here, 4 times 2 plus 1 divided by the denominator, which is 4, and that's simply equal to 8 plus 1, 9/4. Now we're going to quickly look at the procedure for carrying out the subtraction operation on fractions. It is similar to the procedure for carrying out addition. So for instance, in the case where you have a subtraction operation being carried out on fractions with the same denominator, so in this case a over b minus c over b, the result is a fraction whose denominator is the same, and the numerator is simply given by a minus c. For example, 6/9 minus 3/9 is equal to a fraction whose denominator is 9 and whose numerator is 6 minus 3, which is 3. However, for fractions with different denominators, like this case where we have a over b minus c over d, simple way to proceed is first to convert this problem to one involving fractions with the same denominator, and you do that by taking the first fraction and multiplying it through by the denominator of the second fraction, and then subtracting what you get when you take the second fraction and multiply it through by the denominator of the first fraction. Which gives a, so a over b times d over d, same thing as a times d, which is ad, divided by b times d, which is bd, minus c times b, which is cb, divided by d times b, which is db. And as you know, db is the same thing as bd, so it's minus cb for bd. So we have two fractions which have the same denominator, so the resultant fraction has the same denominator, bd, but the numerator of the resultant fraction is given by ad minus cb, which is ad minus cb. And there you go. So for example, 7/10 minus 2 divided by 3 is given by 7/10 multiplied through by 3. So just do that here. Minus 2/3 multiplied through by the denominator of the first fraction, which is 10. So, well, 10/10. And this gives, well, 7 times 3, 21, 10 times 3, 30, minus 2 times 10, 20, divided by 3 times 10, which is 30. So now we have two fractions with the same denominator. So our result is simply 21 minus 20, which is 1, divided by 30. Simple stuff. In the process of carrying out addition, or the addition operation and the subtraction operation of fractions, we've already had to multiply fractions. So it's a bit late to start talking about multiplication, but this is something you've done. So if you have two fractions, a over b times c over d, you multiply them together, you're going to get a fraction. The numerator is given by the product of the numerators of the original fraction, so a times c, and the denominator is given by the product of the denominators of the original fractions, b times d. Easy stuff. I'll just do an example, even though we've done several already. 2/3 times 1/4. The result of this multiplication is a fraction whose numerator is 2 times 1, which is 2, whose denominator is 3 times 4, which is 12. This can be simplified to give 1/6. For dividing fractions, so dividing one fraction by another, the first thing to do is convert the division problem to a multiplication problem because that's easier to handle. That's easy to handle, as you can see from what we did here. In order to do that, so you have A over B divided by C over D, you can replace the division sign with the multiplication sign, but what you have to do with the fraction that follows the sign is take the reciprocal of the fraction. So you swap the numerator with the denominator and vice versa. Or when you just swap them, rather, so ignore the vice versa, you swap them. And then you get, instead of C over D, you get D over C. So you can easily multiply these two because A over B times D over C is A times D, which is AD, divided by B times C, which is BC. So this is easy stuff. I'll give you an example in numbers. Let's stick with this. 2 divided by 3, or 2 over 3 rather, as a fraction, divided by 1 over 4. Simply equal to 2 over 3 times 4 over 1. I'm going to swap the numerator and the denominator of the fraction that follows the division sign. And that gives 2 times 4, which is 8, divided by 3. So it's really easy to carry out these basic operations on fractions. Finally, let's just take a look at a few more examples. So in this first one, we're required to simplify the given expression, and it involves fractions and it involves both addition and subtraction. So we're going to use BODMAS, and in BODMAS you carry out additions before subtraction. So I'm going to first say we'll find out what 4 over 5 plus 2 over 3 is, and then we carry out the subtraction operation. So this is simply equal to what? Well, 4 over 5 times 3 over 3. Remember, you first reduce it to a problem involving two fractions with the same denominator. So 4 over 5 times 3 over 3 plus 2 over 3 times 5 over 5. So carry out the addition first, and then you can carry out the subtraction if you want. So what I'll do is I'll just ignore this for now and continue. Or what I'll do, so the addition part of this expression, simply what you see here, which is equal to, so I've removed the equals to sign that was there, is equal to 4 times 3 divided by 5 times 3, which is 12 divided by 15, plus 2 times 5, which is 10, divided by 3 times 5, which is 15. And this gives 12 plus 10, which is 22, divided by the same denominator, which is 15. So now this expression is now, instead of 4 over 5 plus 2 over 3, we know that that addition, that sum, is 22 over 15 minus 1 over 9. So we have two fractions with different denominators. So I'm going to reduce it to a problem involving fractions with the same denominator. So to do that, you take the first fraction and multiply through by the denominator of the second fraction minus second fraction multiplied through by the denominator of the first fraction. And this gives, well, 22 times 9, you can do that on a calculator, is 198. 15 times 9 is 135. So that's this first multiplication problem solved. Then minus 1 times 15, which is 15, divided by 9 times 15, which is 135. So this is equal to 198 minus 15, which is 183, all divided by 135, because we're subtracting a fraction from another fraction where the fractions actually have the same denominator. So the resulting fraction is going to have the same denominator. So that's the first problem solved. The second problem is easier. It's 1 divided by 12 over 13. So the first thing you can do is say, well, this is the same thing as 1 times 13 over 12. You change the division sign to a multiplication sign, and then you take the reciprocal of the fraction that follows this division sign. And then all you can say is, well, 1 times anything is itself, so this is 13 over 12. Or you could say, well, 1 is the same thing as 1 over 1. So that's 1 over 1 times 13 over 12, which is 1 times 13, divided by 1 times 12, which is 12. Now, in a scenario where this was actually 2 divided by 12 over 13, you could say, well, that's equal to 2 times 12 over 13, 2 times 13 over 12, 13 over 12, and I'll just continue here. Okay, well, and you can say, well, 2 is 2 over 1. So you can then say the result, which would be on another line, because you don't want two equal signs on the same line, is 2 times 13 divided by 1 times 12, which will give you 26 divided by 1 times 12, which is 12. And you can simplify this.